At 7:05 p.m., witnesses heard a loud cracking sound. Moments later, the fourth-floor walkway collapsed. It fell directly onto the second-floor walkway below. Both structures then crashed onto the crowded lobby floor. Thousands of pounds of steel beams, concrete, glass, all falling in seconds. The collapse killed 114 people. More than 200 others were injured. It remains the deadliest structural collapse in modern U.S. history. Emergency responders described the scene as chaotic. Survivors trapped beneath heavy steel beams. Rescuers cutting through debris. Some victims pinned for hours. The rescue effort continued throughout the night. But for many, help came too late. After the disaster, investigators searched for the cause. What they discovered shocked the engineering world. The design change during construction had doubled the load on a critical connection. The steel box beams supporting the upper walkway simply could not carry the weight. When the structure reached its limit, the connection failed. Once the first joint broke, the entire structure collapsed. In engineering terms, this is called progressive failure. One component fails, then the entire system follows. The tragedy was not caused by one catastrophic event. It was caused by a design oversight, a change that was never fully analyzed. The investigation led to severe consequences for the engineers involved. Their professional licenses were revoked. It became one of the most significant disciplinary actions in engineering history. But beyond legal consequences, the disaster forced the entire construction industry to rethink how projects are reviewed. Today, structural design changes must go through rigorous verification processes. Multiple engineers review calculations. Independent inspectors verify safety. Because the lesson from Kansas City was painfully clear. Even small design decisions can have enormous consequences. The collapse changed engineering education across the United States. Universities now teach the disaster as a case study in structural ethics. It highlights two critical lessons. First, engineering decisions must always be verified through calculations. Assumptions are not enough. Second, responsibility cannot be shared vaguely across multiple parties. Someone must always be accountable for structural safety. Because buildings are not just steel and concrete. There are spaces filled with people. And when design fails, lives are at stake. Today, the site of the collapse looks peaceful. Visitors walking through the area might never imagine what happened here. But the memory of the disaster continues to influence engineers around the world. The collapse of the Hyatt walkways wasn't caused by nature. It wasn't an earthquake. It wasn't a storm. It was a design mistake. One small change, one overlooked calculation, and one reminder that in engineering, the smallest details can carry the greatest weight. On the evening of July 17, 1981, hundreds of people gathered inside the elegant atrium of the Hyatt Regency, Kansas City. Music echoed through the massive lobby. Couples danced across the floor. Above them, suspended from a ceiling, two glass walkways stretched across the atrium. They looked beautiful. They looked safe. But hidden inside the steel structure above the crowd was a mistake so small, most people would never notice it. A single change in the design. One detail. And at 7:05 p.m., that mistake turned into one of the deadliest structural failures in American history. In seconds, thousands of pounds of steel and concrete came crashing down. The dance floor disappeared beneath twisted metal. Screams replaced music, and 114 lives were lost. This is the story of how a simple engineering decision became the deadliest design mistake ever made. When the hotel opened in 1980, it was considered one of the most impressive buildings in Kansas City. The centerpiece was its enormous atrium lobby, 7 stories tall, glass walls, elevators gliding up the sides, and most striking of all, 3 suspended walkways crossing the open space. They allowed guests to walk from one side of the hotel to the other while looking down at the lobby below. From the ground floor, they looked like floating bridges. Elegant, modern, but beauty in engineering must always be matched by something more important. Strength. The original design called for the walkways to hang from long steel rods attached to the ceiling. These rods would pass through the upper walkway, and continue down to support the lower one. It was a straightforward structural system. One rod, two walkways, load distributed evenly. But during construction, a contractor suggested a modification. Instead of one continuous rod running through both walkways, they proposed splitting it into two separate rods. One rod would hold the upper walkway. Another rod would hang the lower walkway from the upper one. At first glance, the change seemed harmless. But in structural engineering, small changes can double the forces on critical connections. And that's exactly what happened. The new design placed twice the weight on the connection supporting the upper walkway. Without proper recalculation, without thorough review, the flaw was now built directly into the structure. Before the disaster, there were already signs that something wasn't right. Construction workers reportedly noticed sections of the walkways bending during installation. At one point, part of the atrium roof even collapsed during construction. But the project continued. Inspections were limited. Design responsibility was divided between multiple parties: engineers, contractors, fabricators, each assuming someone else had verified the safety of the change. This is a dangerous moment in complex engineering projects, because when responsibility becomes unclear, accountability disappears. July 17th, 1981, the hotel hosted a popular weekly event, a tea dance. Hundreds of people gathered in the atrium. Couples danced below. Others leaned against the railings of the suspended walkways above. At the time, the two walkways were supporting far more than their original design load. People stood shoulder to shoulder along the railings, watching the dance below. The structure above them was under enormous stress. But no one in the room knew, because structural failures rarely announce themselves. They happen suddenly, and when they do, the consequences are immediate.